Hello, welcome to Apache Hadoop 3x course. I'm Abhijit Sakuja from UpDegree, and in this video we are going to look at an introduction to Hadoop 1x. So what exactly Hadoop 1x is all about? So first of all, to understand Hadoop 1x, we are going to divide this into a separate part, not spending too much time on it because it is really important to understand that how exactly the first generation of Hadoop works, and then we'll go to the second, and then finally we'll land up to the third one. So here we are going to take a look like what exactly the high level architecture of Hadoop 1x and what are the different components of Hadoop 1x. How does this work and what is the storage and computation layer that we have in Hadoop? So first of all, looking at the architecture, that's a very high level architecture which is further divided into four parts. So one is your Hadoop Common module, HDFS, MapReduce, and Hadoop ecosystem. Whenever you want to connect to Hadoop in Hadoop 1x, you have to basically use an API. And that API is what we can see in Hadoop Common module, is where you will allow all the components which has been built around Hadoop to connect to your Hadoop. So the components, for example, like if you want to connect to Hive, you want to connect to Pig, or any other components which you'd like to run on top of Hadoop, it actually uses Hadoop Common modules as a base API. So it is a jar file which is still available if when we are going to go inside Hadoop folders, there is a jar file which is called as common, which helps you connect to your Hadoop environment. The second one is HDFS. This is Hadoop Distributed File System, which is actually a file system that Hadoop uses. And why it is called as distributed? Because of course we are working in a distributed environment where we have multiple machines. So that's why it is called as distributed file system. So understand one thing: the Hadoop basic idea behind Hadoop was not the computation. Like, it was first of all initially as a distributed file system, and then they added the computation layer, which is the MapReduce, and therefore it becomes a combination of two things, which is one is HDFS, another one is the MapReduce. So think about HDFS is just a place where you go and store. The only difference in this storage is this is distributed. So there you're going to have multiple machines, so you go and store your data on the multiple machines. So when you store, just take an example. If I have a machine and I'm going to store a file which takes 60 minutes, if I add 6 machines, right, means 5 more machines and total becomes 6, what is the time that it is going to take if I'm going to store the file in parallel? So it is straight away 60 by 6, which is 10 minutes. Now it is going to store the file rather than 60 minutes. So therefore, when you make your file system as a parallel, as a distributed, as going scaling horizontally, then it becomes really beneficial to read and write the data in a distributed fashion. So that is the whole idea, that if we increase the number of machines, or of course the storage, whatever we are writing, whatever we are reading, and whatever we are computational will become reduced. So the actual time has been reduced when we talk about the distributed file system. Then we also have another, which is your MapReduce. So this is your computational layer, which is your classic MapReduce for data processing. So whenever you want to process any data on Hadoop 1x, and the data is stored onto your Hadoop distributed file system, it can be processed using your MapReduce. So MapReduce is actually a combination of two words, that's a map and the reduce, which we are going to take a look at a later part, maybe in the next session or next to next session, where you're going to see that how exactly this MapReduce works as a on top of your HDFS. So with Hadoop 1x, this MapReduce was embedded. What does it mean? Like, if you want to process any kind of data on Hadoop in 1x, you have to have run MapReduce on top of it. There is no other way that you can run any other processing engine on top of Hadoop, which is now possible, right? And we are going to look in Hadoop 2x how it became possible, starting with 2x, that you can run any other computational layer, and MapReduce just become an application on top of Hadoop 2x. But with 1x, it is completely embedded. You run anything, it will run MapReduce at the background. So therefore, some of the people still think that Java is the most important language for Hadoop because you have to write the MapReduce program in Java, and that's how you're going to run development job on top of Hadoop. No, that's not the case. That was the early days of Hadoop, but now it is like MapReduce becomes just an application. So there are many other programming languages which takes part on top of Hadoop, and if you know them, you can become a successful developer on top of as a big data developer on Hadoop. And then finally we have the 4, which is Hadoop ecosystem. So this is the components that has been built around Hadoop. As I said, like whenever you want to connect to Hadoop with your ecosystem components like Hive, Pig. So in that way, you have to connect through Hadoop Common module. So all those components can work on top of Hadoop. So it is not just like you were working on MapReduce every time you have to write the Java code. No, there are other components also which can take part in Hadoop for doing the computation and making the storage reliable, making storage easier on top of Hadoop. So there are many ecosystem components out there, which again we are going to talk later part. So differentiating that if you want to process the data, what are the different components? If you want to do an ingestion, what are the different components? Or if you altogether want to do some different kind of analytics, so what are the different types of components that can be used on top of Hadoop? So that's a high level here. So as I said, like there are 2 major parts of Hadoop. One is your HDFS, another one is the MapReduce. So if we take HDFS in Hadoop 1x has basically 3 most important components. One is your name node, secondary name node, data node that comes under HDFS, and under MapReduce become the job tracker and the task tracker. So now let's talk about what exactly this name node, secondary name node, and data node is all together. So name node, think about as a master slave architecture, because Hadoop is actually been meant for master slave architecture. So what is a master? Master is the one which takes care of the metadata of your cluster. So that's the master we are talking about, which is your name node. So any request that you are sending within the cluster, it always first of all goes to the master, and then only master will say, okay, I have the request, now you can store the data in this particular place, and this particular place. But where exactly that storage is? That storage what we call as a slaves, and those slaves are the data nodes, right? So data nodes are the one where you have the actual storage being done. So in our case in HDFS, a name node is your master and slave is your data node where your actual storage gets where your actual data gets stored. So what exactly this secondary name node is? Now what happens, like if at later stage something happens to my master who's taking care of the complete metadata, if the metadata is gone for the cluster which has the information, for example, okay, I have a file which is stored in this particular data node 1, 5 and 7. If the metadata is gone, of course nobody able to come to know that where exactly the data is stored. So in that way, in 1x we have secondary name node, but secondary name node is something which is a manual backup of your primary name node. So if anything happens to your name node is a single point of failure in Hadoop 1x. Then if primary fails, then you have to make your secondary name node back to the primary with a manual intervention. So that was the problem with 1x, but in the next session we are going to talk about like how secondary name node works and what are the manual steps you would need to do to make it a primary name node. Then in MapReduce, we have a job tracker and the task tracker. So here again, we have the same master slave architecture. So job tracker is your master and the task trackers are the slaves. So job tracker is the one which will say you want to process any data on top of Hadoop, right? Using your MapReduce. So the scheduling, the tracking of the job, where exactly the job will be running, all things are done by the job tracker. And who does that work? It's actually the task tracker is doing the work. Okay, I want this much memory to process the data. I need this much CPU to process the data. And who is going to completely process the data? Which is your task tracker. So again, here we have the master and the slave architecture. So these are the Hadoop 1x component, but in the next video we are going to take a look like when you want to write a data, how exactly it is written on Hadoop, and when you want to read a data, how exactly it is read, and if you want to process the data, how your job tracker and task tracker reacts, and what is the procedure, what is the steps they follow to process your data. So this is what we have in Hadoop 1x when it is going to work. So as I said, like we have the master. So here you have the name node and the job tracker as the master. So you can see that secondary name node is sitting. I'm not pointing any link over here between the secondary and the name node because I want to show you that how exactly this thing works, rather than not spending too much time on that, because this is really not important at today's stage because nobody is using it, but just to have an understanding that where exactly the secondary name node fails to save your cluster and why the name node is called as a single point of failure in 1x. So this is the question which may comes in some of the interviews where people still wanted interested in to know what happens with 1x, although it's not relevant at all. This is what your master services like secondary name node and the job tracker, and at the bottom you can see that those are called the slaves. So if you see that the slaves I have mentioned as data node and the task trackers, yes, those are the slaves. But remember one thing, these two services run within the same machine. So data node and the task tracker will run on the same machine. So if I'm showing you over here that this one machine, second machine, third machine, and the fourth machine, and so on, like, because this is a distributed environment. So whenever your data gets stored into this machine, the second machine, the third machine, and the fourth machine. And when you want to process the data, we have terminology which is called as data locality, which means that the computation happens where you have your data available. If a file data is available on data node 2nd and data node 4, so the computation for that file will happen on data node 2nd by the task tracker sitting on the same machine and by the task tracker sitting on the 4th machine. So that is how your data get actually processed wherever, means the computation happens where the data lies. So that's called the data locality. So that's what we have in this session, and in the next video we are going to take a look how the read and write happens on Hadoop, and how exactly we are going to MapReduce is going to compute within the cluster using job tracker and the task tracker. Thank you so much. Hi, welcome to Apache Hadoop 3x course. I'm Abhishek Sakuja from UpDegree, and in this video we are going to continue with Hadoop 1x introduction. So in the earlier video, we have looked like how Hadoop 1x works, but let's take a little bit more deeper insight, like how Hadoop 1x looks like and what are the major components in it and how exactly it works. Why we are doing this? Because going to 3x, it's not just like you start with 3x and everything works well and without any fundamental understanding, because understanding 1x, 2x, and 3x will make you a perfect, getting a difference that why exactly there was a need of Hadoop 3x, what is the disadvantages of 1x, and why 2x was there, and why finally we have 3x. So that's the reason that we are doing an introduction, and you'll see that most of the components are same in 1x, 2x, and 3x, but there are some changes which has enhanced the product. That's the only case that we are looking for an introduction to 1x and 2x. So in the previous video, we have already taken a look that this is the client, then we have name node, we have job trackers, we have machines where we have the data node and the task trackers. Also, we have the one of the master node, which is a secondary node. So we are going to understand one by one what exactly it is. But before that, let's take a look between the storage and computation layer. So Hadoop is divided into two parts. One is your storage layer, another one is a computation layer. So the storage layer is called as HDFS, and it's going to be continued to be same whether it's 1x, 2x, or 3x. So that is called HDFS, means Hadoop Distributed File System. So think is just as a file system, nothing more than that. But the only difference is that it is a distributed file system, which is the file system is distributed over multiple machines. So here the data is replicated. Now in Hadoop, what people do generally, they do not really care about the backups, right? Although yeah, disaster recovery is a separate case, right? Archival is a separate case, but when it comes to the data backup, it's different, because here the data is replicated 3 times, which means that you store one file, there will be 2 additional files which will serve as a backup for you. So therefore the data is replicated 3 times. Data is stored in the form of blocks. If you are storing one file, How do you make sure that the file is stored on n number of machines, like horizontally or in a distributed fashion? Of course, you need to divide the files, and that division of the files is called the blocks, and each block is of 64 MB. It is configurable, like you can configure your block size, but with 1x by default it is 64 MB, but in 2x we'll see that it will change. Each file is divided into number of blocks. That's what I just explained, that the file has to be divided into the number of blocks, which is of each of 64 MB, and then your file will be stored on n number of machines. And name nodes store all the metadata information. So when the data you're trying to store the data, and the data gets stored into your data nodes, the name node is the one which have all the metadata information, like this is the file and where exactly it is stored, which is the data node that the file is currently stored on, the block of the file is stored on, and how many times the data is replicated and where it is replicated. So all this information is contained at name node. These blocks are stored on data nodes. Then we have the computation layer, which is called the MapReduce. This is a data locality computation. Now, what is a data locality computation is, wherever you have the data, the compute happens at the same place. So that is the data locality computation. You do not move your data to the computation layer, you just move your computation to the data node. So that's why Hadoop becomes popular in the computation line, as we are not moving the data, instead we are moving just a computation. Data is processed in stages of map and reduce. So that's why the name has been given as map and reduce. So you map your data, right, whatever the logic that you have to map the data, and then you try to reduce. The reduce is actually your computations, where your CPU utilization, you're doing some aggregations, grouping, all these ordering. So everything, the computation related to that goes into the reduce layer. Which we are going to see an example just after this as well, like how exactly when MapReduce runs, what really happens. Each block of data represents a split for processing. Now, whenever you have a MapReduce running, now think that the data has been stored in n number of blocks. You have one file which is stored in n number of blocks, and you want to process that file. So the n number of blocks is always equals, or is considered as a split for processing. So one block is a split, the second block is another split. As if you have 10 blocks for a file, then means there are 10 splits for processing. Auto failure task recovery. So in between, if any of the tasks fails, the job tracker is responsible for restarting that task on the task tracker. Embedded layer on Hadoop 1x. With if you're processing anything with 1x, which you're not going to do actually, because nobody uses Hadoop 1x, it's almost forgotten, but the concepts of Hadoop remains the same. So at that point of time, this MapReduce was an embedded layer on Hadoop 1x, and that's what it has been continued. All right. So this is what happens in the storage layer when you try to write. So say about like you have a client which is given as HDFS clients, and it is running in client JVM. So first of all, what you'll do, you'll create your distributed file system. You'll say that I want to create a file, so it will go inside your JVM client, and there is already a client which is your distributed file system, and say yes, I would like to create a distributed file system, and that information will go to the name node. So it will say that, I want to create a file, so could you please help me create a file. So name node say, okay, definitely I can help you to create a file, and it gives the information to the client that where you should write. So the name node will say, I have this particular data node available, this particular data node available, and this one. So you just go ahead and write it. So therefore, HDFS client will start writing the FS with the help of FS data input stream. So if you can see, start from here, and then it will start writing the package. Now you'll observe one thing. The name node gives the information about all the data nodes and where the replicated copies goes, but the client is only responsible to copy on the primary data node. So therefore, the write copy goes to data node 1, right? And data node 1 will be responsible to copy on data node 2, and data node 2 will be responsible to copy the data node on 3. So this is how replication is going to work, right? So the replication happens in parallel, and the blocks happens in sequential. So that is the difference. And once each of the data nodes complete, it sends the acknowledgement back to the particular data node. So if, for example, data node 3 is completed, so it will send the acknowledgement to data node 2, it finishes, it goes to data node 1, and final acknowledgement goes to your FS data stream, and therefore the HDFS will close it. So this is how and finally the information will be sent to the name node saying that yes, I'm done and I would like to close the connection. How about the read? Read is almost the same. Right, if you can see that HDFS clients again open a connection with distributed file system, it will go to the name node saying that, oh, I need these blocks because I would like to read this file. So can you give me the block location? So it will say that, okay, I will give you the block location. Once the HDFS client will know to the block location, again it will go to FS data input stream and say that I would like to read. And that input stream will connect to the node where your data is stored. Say about like your data node only stored in data node 2, data node 3, and data node 10. So it is going to connect to those data nodes directly, and then it will read the data from there. Once the data has been read, right, and the read happens in parallel. Say about like you have 10 blocks, so the 10 block read will happen parallelly because it will go to each of the data nodes to read the data, to read those particular blocks of a file. Once the data has been completed, the connection will be closed by the HDFS client. Then this is your computation layer design, where you will see that we have different stages in MapReduce. So this is a MapReduce layer. So you can see there is an input, splitting, mapping, shuffling, reducing, and final stage. So what exactly happened in the input space? Say about like you have a data, and the data is stored in the form of blocks. So each block will represent a splitting. So you can see that we have a deer, beer, river, car, river, deer, car, beer. And then actual mapping happens. So mapping is your mapper layer where each of the word is what we are doing. We are just giving it one to each of these layers. So you can see that the deer is mapped with 1, beer is 1, river is 1, and so on. And after mapping layer, there's a shuffle layer. So data gets shuffled so that the words can bring together, because this is a word count program we are doing. So the words can shuffle together. So beer will come together 1 1, car will come 1 1 1, deer 1 1, river 1 1, and finally we reduce. So as I said that the reducer is your computation layer, so it becomes beer 2, car 3, deer 2, river 2, and finally you have your result, which is as one input, as a one output file from your MapReduce layer. I know that this is a very quick introduction to MapReduce, because you need to go more if you would like to understand the MapReduce. But in later session, we are going to just review one example as well, where you'll see that how exactly the processing works. And finally, we let's know about the secondary name node as well, because I would say this is also an important feature in 1x, but now you do not need to really know it, but just for the understanding. Say about like you have a primary name node, and then we have a secondary name node as well over here. So what does happens? There are two files inside the primary nodes, which is called edits and fs image. So edits is the one, it's the changes that you make in your name node get stored in your edit logs, and the final copy of the edit logs is always stored in the fs image. So what does secondary name node do? Secondary name node has a checkpoint, or we also call it as a checkpoint node. So say about the checkpoint is 10 minutes. So every 10 minutes it copies the edit nodes and fs image into the secondary node, merge into the final fs image, and send it to the name node. So then the name node has a copy of fs image, and it will use that checkpoint. So if anything happens to the primary node, you can make your secondary name node as a primary up to a checkpoint period. The last checkpoint that if you have done 10 minutes, then you can do the check, then you can recover your name node up to last 10 minutes of period, right? So in that way, but this is a manual task, therefore it is not considered a good idea to use in secondary name node to be in the Hadoop ecosystem, and therefore 2x is changed and it is continued with 3x as well. Alright, so this is what we have in this session, and in the next video we are going to take a look at introduction to Hadoop 2x. Thank you.